And what did we start with? We started with a triangle. Let's do another problem where we're not going to start with a triangle. Instead, we're given the fact that the cosine of theta is 5/6. And we want the same information, so a good starting point to solve this problem would be to go ahead and draw yourself a triangle. Alright, so we've got our triangle here, and let's label our theta. Now, it doesn't matter which one you choose as your theta, as long as from there you're consistent as you work through it. Let's remember, what is the cosine of theta? The cosine of theta, if we think about this for just a second, is then going to be the adjacent over our hypotenuse. So what is our adjacent here? Looking, since we're given that it's 5/6, the adjacent must be a 5. The hypotenuse must be a 6. That just leads us this side over here, our opposite side that we don't know. We don't know what that side is. All right, but what can we use? We can use Pythagorean's theorem to go after this, can't we? So let's go ahead and complete our triangle up. So we're going to have a 6 squared equals our opposite. I'm going to go ahead and label him OP squared so it doesn't look like a 0, plus 5 squared. 6 squared is then 36. That's going to give us then OP squared plus 25. Subtract 25 from both sides. And we end up with the opposite side squared equals 11. Now, if I take the square root of both sides, right, what information do we get? The opposite side is then just equal to the square root of 11. So this side here is then going to be the square root of 11. Now remember, whenever we have a square root, we need to look to see if we can reduce it. This one, can't reduce it. We're done. At this point, then, we can write down our trigonometric functions. Cosine was already given to us. Let's go ahead and write that one down first. Take the easy ones first. And we know the cosine of theta is then going to be 5/6. And let's write down, right beneath it, its reciprocal function, which for the cosine, the reciprocal function is going to then be the secant. So for this problem, we know that the secant then is going to be 6/5. All right, our next function, let's go ahead and do our sine. Remember, what is the sine? The sine is then the opposite over our hypotenuse. So that's going to then be the square root of 11/6. Now things get a little interesting when we look at the cosecant. Because the cosecant is then going to be 6 over the square root of 11. Under no circumstances do we leave a radical here in the denominator. So what are we going to have to do? We're going to have to multiply the top and the bottom by the square root of 11. And that's then going to give us the result that we'll end up with 6 square root of 11 divided by 11. All right, two functions that we need to look at. We need to look at the tangent. And remember, the tangent of theta is then going to be the opposite over the adjacent. So what's that one going to be for this one? We look back at this triangle up here. We look up here at the triangle. We're going to have the square root of 11 over 5. All right, and then we can get the cotangent, its reciprocal identity. and that's going to be 5 over the square root of 11. As we have discussed previously, we never leave our square roots in the denominator, so let's go ahead and move it. Multiply the top and the bottom by the square root of 11 to rationalize out that denominator, and we get 5 square root of 11 over 11. And we now have completed this problem. We have all 6 trigonometric functions. Review, what did we do? Looking at the original problem, here we then wrote down our triangle, and from the triangle we could read off our trigonometric functions. Now, sometimes the author likes to throw stuff like this at us, where we have the cosecant of theta equals 9. What did we do on the last problem? We drew a triangle. But let's rewrite this real quick. What do we have going on here? We have the cosecant of theta, and I'm going to rewrite this. Instead of 9, I'm going to write it as 9 over 1. Because once we do that, then you can start to see how we're going to be able to draw out a triangle with this information. So let's go ahead and get a triangle here. Okay, and we'll label this corner here theta. Now let's remember what the cosecant is. The cosecant is the hypotenuse over the opposite. So we're going to have a 9 on this side and a 1 on this side, and this adjacent side, he's unknown. We'll make him an x for now. So we can go ahead and write out using Pythagorean's theorem. We have 9 squared is then going to equal 1 squared plus our x squared. 9 squared is then going to give us an 81. 1 plus x squared. Subtract the 1 from both sides, so x squared equals 80. Square root. Alright, what's going to happen here when I have the square root of 80? What can we do to this? We can reduce this radical. What do I know about the square root of 80? I know the square root of 80 is also then known as the square root of 16 times the square root of 5. Alright, the square root of 16 is then going to be 4 square root of 5. So this side, this adjacent side here on the triangle is then going to be 4 square root of 5. Now I've completed my triangle, I can start writing down all 6 of my trigonometric functions. So what do we know about the sine of theta? Remember, that's the inverse of that cosecant, so that's going to be 1/9. Let's go ahead and look at then the cosine of theta. The cosine of theta is going to be the adjacent over that 9 there, so that's going to then be 4 square root of 5 divided by 9. Our next function, we'll go ahead and write down the tangent of theta. Remember, the tangent is opposite over adjacent, and so what's going to happen with this tangent? We're going to have 1 over 4 square root of 5. Alright, we got that problem again, right? We have a radical hanging out in the denominator, so let's get rid of him. We're going to multiply the top and the bottom by the square root of 5. When we do that, what's going to happen? On top, we're going to have a square root of 5. On the bottom, we're going to end up with a 4 times. Now look, when I multiply these 2 square roots together, they're just going to give me a 5 back. So that's then going to be square root of 5 divided by 20. Alright, so let's go ahead then and get our other 2 functions that we need. We have the cosecant, so we need the secant function. Remember, this function is reciprocal of our cosine, so this is going to be 9 over 4 square root of 5. You got to get rid of that denominator. Square root of 5 over the square root of 5. I'm going to multiply the top and the bottom. And then we're going to then have on the top 9 square root of 5 divided by 20. All right, and we have one more function, and that's the cotangent. And this one is anticlimactic because it's going to be 4 square root of 5 divided by 1, which just leaves us then with a 4 square root of 5. And now we have looked at a couple of different ways to find all 6 of our trigonometric functions from a right triangle. Let's review the steps that we took to get here. First thing we did is go ahead and draw a triangle. Once you've drawn the triangle, you can then start writing down your trigonometric functions. As a word of warning, go ahead and memorize those trigonometric functions, and here is a way that some folks do it. It's called SOHCAHTOA. SOHCA stands for then sine is then our opposite over our hypotenuse. Co is then the cosine, which is then going to be our adjacent over our hypotenuse. TOA is then our tangent, which is then our opposite over the adjacent. And you'll notice that's where those letters all come from. This concludes our discussion of trigonometric functions of a right triangle.